In this video, I'm going to talk a little bit more about the Monty Hall problem and offer perhaps an alternative explanation as to why switching windows is in fact the better option. So let's say for the sake of this demonstration, we have our three windows. I've just drawn three circles there. So we have window 1, window 2, window 3. One of these windows will be a winning window. The other two will be losing windows. So it doesn't really matter which two windows I choose. So let's say, for example, let's say pick window 2 or 3. So these two windows, the probability of a loss is going to be 2 on 3. Okay, so that also means that with any of these two windows, the probability of a win is equal to 1 on 3. And let's just say as a contestant, I happen to have chosen window number 3, for example. So it doesn't really matter. Whichever window I choose, I'm going to pick that window and another window as potential losing windows. In other words, the probability of a loss is going to be 2 on 3. So this is my choice. So I know that I've got a 2/3 chance of losing, which means a 1/3 chance of winning. So let's say then that the host then comes along and reveals the contents of one of the two other windows. So let's just say that the host reveals the contents of window number 2 and reveals window number 2 as a losing window. And of course, the host knows, well, we're assuming that the host knows what is behind the windows. So the host reveals window number 2 and it turns out to be a loss or a lose. Right? So that window is now gone. Now the host offers the contestant a choice. Would you like to stick to, say, let's say window number 3 in this example, or would you like to switch now to window number 1? Now the probability of a loss or a win still remains the same. So in other words, windows 2 or 3, the probability of a loss is 2/3 and the probability of win is 1/3. That hasn't changed. But because one of the windows has now been revealed, and the assumption here that it's been deliberately revealed because the host knows obviously what's behind the windows, that means then that window number 3, the probability of a loss is still 2/3, but it's now solely on window number 3 or the choice of window number 3, not shared between these two windows. So if the probability of a loss is 2/3 now for window number 3, now that window number 2 is out of the equation, well, that means then for window number 1, it's kind of reversed. So if the probability of a loss is 2/3, the probability of a loss for window number 1 must be 1/3, since the sum of the two probabilities must equal 1. They're complementary events. So that means then that the probability of a win for window number 1 must be 2/3. Since 2/3 plus 1/3 must equal 1, 1/3 plus 2/3 must also equal 1, so they're complementary events. So therefore, to maximize my chance of winning, I would say I would change my choice from window number 3 to window number 1, knowing that window number 2 is a loss. So I hope that helps to explain that in a different way, and thank you once again for watching.